If not treated it officially, that's what I mean. So in Java, we have what we call input-output stream, where you get your input and display them. Answer me. You have a class 5 sister. She comes and asks you asked to write 2 output devices of a computer. I'm your class 5 sister. 2 output devices. Homework. Go ahead, write that. Monitor and a speaker. 2 input devices. 2. Stylus. 3. Mouse. 4. 5. Joystick. 6. Gary. I should backwards. Gary. 6. Someone should catch it in the air. Mike. You said speaker. I was expecting Mike. Okay, let's go. So in Java, you have those IOs. So, and there are lots of classes for them. So you'll be looking at them, which one to use, when to use them, how to use them. Most programmers don't like the complexity of the stream classes, but they are easy to use. There are so many, that's why you don't know which one to use, when to use them. So for this slide, we are focusing on all the classes, which one to use the right tool for the right job. So we have 2 main types of streams: byte-oriented streams and character-oriented streams. Byte-oriented streams and character-oriented streams. Each cover input and output. We'll talk about filter streams. So we start. So the I/O system in Java is based on streams. Streams is nothing but what? Something coming in series, just like our stream of water or stream of something. Something is flowing. So when you are getting data consistently from a particular source to a particular sink or a destination, that's where it becomes a stream. So you read from input stream, then you write what? Output stream. So as we said, you have 2 main types: the byte oriented and the what? Character oriented. For the byte oriented, each datum, flow of data. Datum is a byte, and bytes are made up of what? Bits. So you use the input stream class hierarchy and the output stream class hierarchy. There are classes up there. Then for the character base, each datum is what? Unicode character. And in Java, we said the Unicode is what? 16 what? Bits. 16 bits. So it's 2 bytes. It uses the reader and the writer classes. So anytime you are working on any of the classes and the class ends in a stream, it tells you are working on what? Byte-oriented stream. Anytime the class ends in a reader or a writer, it tells you are working on what? Character-oriented stream. Byte-oriented always ends in what? Streams. Character-oriented always ends in what? Either a reader or what? A writer. That's the only trick. And most often you'll be using the character more than the what? Byte-oriented. Because most of the work you'll be doing are characters. Your data will be stored in character. Unless you want to do some encryption where you will store them in binary for faster access. A writer. Either a reader class or a writer class. That's their parent hierarchy. So there are so many different types of byte-oriented string, and they are found in the java.io package. We've talked about the LAN package. That's where the thread is. The thread, I missed one part. Remind me when you are done with this. The thread, you are not done with the example. Done with this one. All byte-oriented streams are subclasses of common stream class. The common stream class. So all of them are coming from there. So you have the input stream as subclasses of the abstract class java.io input stream. So now you all know what an abstract class is. Once the class is an abstract, it means it needs subclasses in order for us to what? Use the class. Or if you don't want to create a subclass, what do you need? Anonymous what? Inner classes. If there's a subclass, an abstract class, and you want to use it, and you don't want to create, you don't want to subclass it or inherit from it, you can use what? Anonymous what? Inner classes. Then you use that one on your abstract class. Output stream are also abstract are subclasses of what? The abstract class what? Java.io dot what? Output stream. As I said, this java.io dot output stream, this is a fully qualified name of what? The class. A class name starts from the package level. So if it's com dot whatever, com dot this dot this dot this, so the class name. So all byte-oriented streams inherit basic methods from their respective superclass. This is normal with inheritance. Some define new methods pertinent to the type of data they work on. So as you inherit, when it gets to your level, you modify it, you add your what? Views to it, and suit it or customize it to suit what you want. Byte-oriented streams are closely related to the IO stream provided by other programming languages like C and C++. It's just like your I stream and what? O stream that you overloaded, but you couldn't answer question on it. The wins. Because it's just 2 lines. Because they are byte oriented, they are suitable for reading what? Binary and what? ASCII data. They are suitable for reading what? Binary and what? ASCII. Binary is what? Zeros and ones, and the ASCII is what? 8 bits. That's 1 byte. So byte oriented do not work well with what? Unicode what? Text, because Unicode are what? 16 bits or 2 bytes. So it's bigger than that. And you have been advised to what? Use the what? Character what? Oriented for what? Unicodes. So this is the whole hierarchy. And this is just a summary. There's more to it than this. So for the byte oriented stream, this is just the byte input stream class. So you have the main abstract class. That's the what? Input stream. It's an abstract class. Then as you come down, byte array input stream. Yesterday we talked about arrays. We talked about arrays yesterday. So we come down. As you come down, you can see you have file input stream, sequence input stream, object input stream, filter input stream, pipe input stream. We'll be looking at all these classes one by one. So it comes down to now. we get it. Scanner, we get it. Now the input, some of the input stream methods, backbenches. I can hear you. The input stream methods. When you are reading, you have the read method. It will block the data until the data is available to what? To be read. So it will be like you acquire a lock on it, just like the synchronize. A thread goes and it will lock it until there is data for it to read, because the read is supposed to read data, and when it goes and there's no data, it's waiting for the data. 2 of the 3 read methods returns the number of bytes read. 2 of the 3 reads method return the number of bytes read, and -1 is returned if the input stream has what? Ended. So if you want to know whether it's ended the end of the file or you've gotten to the end of the file, If your read method returns you -1, it means it returns an integer. So you monitor, read from this. While this is not equal to -1, read the data. So you read the data while the what? That input stream is not equal to what? -1. So when it's equal to -1, it means you've gotten to the what? The end of the what? The data. So you have to stop reading. To know whether you've gotten to the end of the file, the read methods, 2 of them, will always return you what? -1, indicating that what? You have gotten to the end of the file, or the end of the what? That data you are trying to read from a particular source. So to test whether you've gotten to the end, we check while whether if a scanner or your BR, buffer input reader dot read, is not equal to -1, then within your while you start reading your data. And the third one, we said 2 of the 3. There are 3 read methods. The third one doesn't return -1, but it throws IO exception. Input output what? Exception. So immediately it throws that exception, then you get to know what? That what? It has ended. So wherever that you are reading, you put it in what? Try catch block. You put it in try catch block. Then as you are doing your reading, when you go to the end of the file, you throw the what? IO exception, which will be thrown automatically. Then you just catch it. Immediately you get the error, it means you've gotten to the end of it. So there are 3 read methods. 2 returns -1. The other what? Throws what? IO exception. So now you are coming to the 3 main methods. The first one, it reads a single character and returns an integer. The second one reads bytes and places them into what? A buffer. And the maximum size of the buffer, max, is equal to the size of the buffer. And it returns the number of bytes read. So the second one reads bytes and places them into what? A buffer. Now let's proceed. I'll talk about the buffer system. And the third one takes an offset. So this is how it also works. It reads up to the length of the byte and places them into the buffer. The first byte read is stored into the buffer offset and returns the number of bytes read. They are all different sets of method. I don't know which one throws the IO exception, but one of them throws the what? IO exception. Then some other methods. You have the available, returns the number of bytes which can be read without blocking. So it's just like peeping or picking. It just goes to what? Pick the number of what? Bytes available. It will not block it. You know that the read method blocks the what? IO until there is data. But the available method just picks without blocking. Then you have the skip methods. It skips over the number of bytes in the input stream. You have the close method that closes the input stream and release any system resources. Anything that you open in the IO stream, you must always what? Close it. The same with our connection class that we did in the what? Database. You should have closed it. I didn't close it. You should do it. So input stream, as you've already seen, is what? It's an abstract class. So programmers can only instantiate what? Subclasses. Or use what? Anonymous what? Inner classes to instantiate an abstract class. Or use an abstract class. So we are starting with a byte array input stream. The constructor is provided with what? A byte array. A byte array, you know what a byte? A byte is a data type in Java. Smaller than int. Usually used for what? Smaller values like for zeros and ones. So if you are reading binary data, create what? The byte. And byte contains, this byte array contains all the bytes provided by this stream. It's useful if the programmer wishes to provide access to byte array using a stream interface. So if you are interested in byte array, you are working on a byte array. And this byte array is usually when you are reading images. You read an image into a byte array. Then you create it back using the same byte array. So byte array is used the most often in images. Then the file input stream, the constructor takes the file name, file object, or the file descriptor object. You know file descriptor? File descriptor, OS. File descriptor, OS, operating systems. It opens the what? A stream to a file. Then we have the file input stream. Provides the basis for what? Filtered input streams. So we come to the filter input stream. We come to the filter input stream. Now you have the object input stream. The object input stream. We use it to work on what? Objects. We will talk about serialization after this slice. It's created from another input stream, such as the file input stream. We use bytes from the stream which represent the serialized object. Now, when you say serialization, I'll come to serialization. Let's move on. But just know that object input stream and object output stream are usually used for what? Serialization. Serialization. And serialization has to do with the state of an object. We'll come to that. Then the pipe input stream. You know how pipe works in OS. You take one input, you channel it to another output, just like a normal pipe. Take something and put it somewhere. So it connects an instance of a pipe output stream. The pipe represents one-way stream in which two threads may what? Communicate. So you have two threads. One is writing and one is what? Reading format using a pipe. Then the sequence input stream. A lot. I've not even used myself before. Now let's move to the byte-oriented output stream. So you've seen some of the input stream. The ones you should be focused on are the what? Byte array input stream, the file input stream, and the object input stream. There are more. Then the output stream too, this is you have the output stream as well as an abstract class. You have the byte array output stream, file output stream, pipe output, just like the other one, but the opposite. It comes down to a zip output stream. So you can zip your what? Your file. You can also, there's also a zip input stream here, down there. For each instance. Then for the output streams, we are discussing some of the methods. The write methods write data to the stream. We use the what? Read method to write, read from the stream. And we have three read methods or three overloads. And two of them return what? Minus what? 1, indicating we've gotten to the end of the what? The file or the data. Whilst the other one throws what? IO what? Exception. To indicate that we've gotten to the end of the what? The file or the data. Now back to the output stream. The write method writes data to the stream. The data is buffered. What do we mean by buffer? Buffer. Temporary location, temporary storage. So when you are writing, you write onto a temporary storage. Then when you are done, when you close it, before it will be flashed. When I say flash, it will move to what? The permanent storage. So when you are writing, it's just like persisting the data or the commit statement. I don't know whether you've done commit in SQL. Commit statement. So please, this point is very important. Anytime you write, use flash method to what? Flash any buffered data from the stream. If you don't flash it, it is just on the buffer. It has not gone to what? Or it has not taken effect, it has not been sent. When you close, it will automatically what? Flash. But sometimes you want it to flash. Sometimes you are not done, you are just chatting. You don't want to close the link before you send the data. So when you are chatting, anytime I write something to you, I need to what? Flash it. Anytime I write something, I flash it so that I push it to you. I don't, the buffering is just what? Piling them up. So it becomes before it pushes to the final destination. Don't go there. Then it also throws an IO exception if what? An IO errors occurs. And this is what? A checked exception. When you're talking about exception, I mentioned checked and what? Unchecked exceptions. Let me explain them here. Checked exceptions are the exceptions like when you create an array, you don't specifically use the keyword throw new array out of bounds exception. You don't do it. It is internally checked for you by the what? The compiler. So those exceptions are what we call the what? The checked exceptions. The one which are not checked, those are the ones that you specifically use the what? Throw new what? The name of the exception. Like in our case, when you created a constructor and you took the salary exception. When you took the salary in the constructor, you check if the salary is greater than 1,000. You say throw new what? Exception. So that one is what? Unchecked. So we are checking it. So the checked exceptions are what? The system thrown exceptions. The system will automatically check. If it doesn't exist, then to what? Throw it. So the IO exception, memory array out of bounds index and stuff. Then the write also has 3 main methods. They all return nothing. The end writes a single character. Then note, even though the data is an integer, the data must be such that it should be less than what? 255. It shouldn't be greater than that. It should be less than 255. Is it? Yes. It's a single character, but it shouldn't be more than. And you know, each data has its corresponding what? ASCII value. Then the second one takes a buffer. Write all the a buffer byte array or a buffer of byte array. You write all the bytes contained into the what? The stream. So when you are writing a lot of data, you use the what? The byte 1. Byte is more than 1. Then the other one takes an offset and the length. It also writes starting from the what? The offset. So maybe you specify start writing from this stream or from this buffer. So that is the write. Then the flash method. It improves performance. Almost all the output protocols buffer the output. So the flash is just what? Push the data onto what? The actual destination. So data written to the stream is not actually sent until the buffering what? Threshold are what? Met. So you just pile it up. When it's full, then we send it. We come back. You keep writing it. When it's full, then we send it. So when it's not full, but you want to send it, that's why you have to what? Flash it by force. Like you say. So invoking the flash causes the output stream to clear its internal buffer. Causes to clear its internal buffer. Then the close method, it closes the stream and releases what? Any resources. So if you don't want to set a flash, you can just leave it. The close will flash it for you, but it's not advisable. If you are chatting or you want immediate result, you have to flash it yourself. So creating an output stream, just as with the input stream, this is also what? An abstract class. So you have the byte array output stream, file output stream, filter output stream, just like the other ones. But note here, the file output stream, look at the constructor. It takes a file name, a file object, or a file what? Descriptor. Then any byte written to this stream will be written to the underlying file. So if you use the file output stream to open to a file and you write to this file output stream, any file that you write to it will be written to the underlying file because you are pointing to what? A file. And it has about 4 constructors. One will create a file. The other will append the data to it. The other 2 will delete it. We will look at them. But I want you to look at one particular. Okay. It has one constructor which allows for appending to a file. So like this one, file output stream. This is the file name. So if the file already exists, it will append to it. It will not what? Delete it. But if you don't append it, it will go and what? Destroy the file and create a new one. But if it doesn't exist, it will create what? A new one. If it's there to clear the content. But if you don't want to lose the old one and you want to go and append the data to the existing one, you pass what? A boolean value true. True indicating that go and append to this file. Don't go and delete what is already existing. Then the same with the filter output stream. Provide basis for filter streams. Then the object output stream, as I said, it's used for serialization. Serialization, we'll come to it soon. Then the pipe, just like the pipe, you write and read. So there's a typical example here, which we'll be trying our hands on, but let's go through the code first. This class is just what? Copy file. It has a method copy file. it takes the file name, input file, and the what? Output file. So you just want to copy from one file to what? The other file. So let's look at the classes that were used. For the first line, you have file input stream because you are inputting from what? A source. Just like any other object, new file input stream, and then it takes what? A string, the name of the file, which is coming from here. So this guy comes here. Then you have the file output stream. That's where you want to what? Write to. So you are reading from here, you are writing to this file. So file input stream, file output stream. Then you have byte. Buffer is equal to new byte of this. So you are creating a what? A buffer of the data that you want to write. So you are just allocating some buffer. Then just create an integer to specify, to know whether there's data in there. Then we check while length is equal to what? File input stream. The dot read method is associated with what? All the what? Input streams. So once we've created an instance of the input stream, we can read the content of that file. So while file input stream dot read, then you pass the buffer to it, is greater than this buffer dot length. You just created some buffer here to specify whether the data is there, whether there's a data there. If this is greater than this, then you what? You write it to another source. You write it to another buffer. This file output is just like you are taking one source. So while there is data here, write it and put it here. So while the file input stream get the buffer and there's data there, buffer dot length, you check the length starting from index 0, that's the offset. Whilst that one is greater than 0, you do what? You write to the file. So this f output stream will write to this file because you've already binded the what? Output file to the what? File output stream. You've already binded the output file to the what? File output stream. So anything we write here will be written to what? This guy. You just create a buffer, read the content into the buffer, then you write from the buffer into the what? The output file. So this is the input file, this is the output file, and I'm the buffer. I'll go and check. If there's data that I write onto the buffer, then I'll push from the buffer into the what? The output file. So that's why we are writing using the buffer. Then after that, we flash it, we close it, we close it. We close the output stream, we close the input stream. Then IO exception if it doesn't what? Exist. Let's just code this one for us to see.